Assalamu alaikum. My name is Hamza Masood and my registration number is 16T49. I am a student of UT Texla Telecom Department. Let's start our lecture. Welcome to lecture number 5. In our previous lecture, we have studied some basic operations one by one, such as amplitude scaling and reflection property, reflection operation, and time scaling. Now we apply all these operations on a single signal. We will look at this example. Y of n is equal to x of minus 3n plus 2. So what are the criteria to apply these operations on a single signal? We will first apply shifting property, time shifting property. Then we will apply the time reflection or flipping property. Third, we apply the amplitude scaling. In order to solve this complex system, we must follow this step by step. First we have to apply time shifting property, then time reflection, and then amplitude scaling. If we first apply the amplitude scaling and then time shifting property, then the result is not correct. So let's see this an example. We can solve this question, as I said previously, with two methods. First we draw this signal and then apply these property, or either we can solve this without drawing signal. We have input signal x of n is equal to 3, 1, this is our zero index value, 2 and 1. Now we'll apply these properties one by one. X of n plus 2. First we will apply the shifting property and we will get this signal. The index value is shifted 2 sample to the right. Now x of minus n plus 2, we have applied the reflection property. If there is no reflection property, do not apply reflection property, apply scaling property if we have a scaling factor. So we have reflection property. First we will apply the reflection property and then we will apply the time scaling property, and if we have amplitude scaling, then we can apply amplitude scaling. If one of these property is missing, don't apply that property, skip the property. Okay, and minus 1 we'll first write this index value 2, and here to the right, all the right values are written in left side of this sequence. There is only one, so we have write this 1, and to the left side of this sequence all these values are written to the right side, like this and like this. So here is only 1, we have written it, and here is 0, 1, 3, we have write it 0, 1 and 3. Then we apply the time scaling property. There is time scaling, so we can apply minus 3n plus 2. In scaling property, what we do, we take 3 of n is equal to 1 and n is equal to 1 by 3. So we will skip the sample 3. These two samples are skipped. this is, and of before this one we know that is 0 and 0 and it's continue till minus infinity, and after 3 we know that it is 0 and 0 and it continue till infinity. So if we compress this signal by a factor of 3, we write 2 and then we skip these two samples and write the third value because it is compressed by a factor of 3. So we have write it 3 and then we know that 0, we will skip 1 and 0 and we write here 0, and this is our required signal. This is nothing but y of n. We do not apply the amplitude scaling because there is no amplitude scaling. We will skip this property. Now we have first learned that we have two basic signal, impulse signal and unit step. So we see that why this unit impulse is called as basic signal or core of this DSP, digital signal processing. So let's suppose the impulse signal, we can write it as delta of n is equal to 1 at 0 index, and all values here are zeros from minus infinity to infinity. All these values are also 0. So we have time shifting property. Let's say g of n minus 1, which is equal to 0. This is minus 1, our index value is shifted here, and 0. And if we apply the amplitude scaling, we get 2 of delta of n, which is equal to 0, 2 and 0. This means that we can write any discrete signal in terms of this impulse signal. Let's suppose we see this example, we see this concept with the help of an example. Let's suppose x of n is equal to 2, 3, minus 1. So we will take 3 impulse and write it in the form of this signal. First we will take, this is our index value, x of impulse delta of n, will scale it with 2, and this is minus 1, we shift it to minus 1. This will become 2, 0, and our next signal, impulse signal, is 3 delta of n, which is 0, 3, 0, and next impulse we need is minus 1 times delta of n plus 1, and this is equal to 0, 0, minus 1. Now if we sum all this impulse, we will get 2 of n minus 1 plus 3 of delta of n minus 1 into delta of n plus 1. If we sum all this signal, we will get 2, 3, and this is our 0 index value, and minus 1. We have sum all this value and these values, and we will get this signal, and this is nothing but x of n. So we have write this x of n in term of all these impulse signals. So if we see this its generalized form, it is x of n is equal to summation k is equal to minus infinity to infinity x of k into delta of n minus k. So we take the value of x of n at a particular index and multiplied it with a shifted version of impulse signals. Here we have take the value at one index and scale it by 2 to make this part, and we have applied the summation and get this signal x of n. Now we will look at another example. Let's suppose x of n is equal to 1, 2, minus 1, and this is 0 index value. Now we can write x of n as n plus 3 plus 2 into so we have write this signal in term of impulse scaled and shifted impulse signals, and I have skipped the term delta of n minus 1 because it is 0. Here it is delta of n minus 1, n minus 2, n minus 3, and n minus 4, and here it is n plus 1, n plus 2, and n plus 3, and this is delta of n. Now we will see what is impulse response. If we have a system and we apply here input signal, and we will get the output signal y of n. The impulse response is such that if this input signal is nothing but unit impulse signal, then we have the output y of n is equal to h of n, and this h of n is known as the impulse response. So this is all about the impulse response. Let's see this with the help of an example. Here we have example that y of n is equal to x of n minus 2 into x of n minus 1 plus x of n plus 2. We have to calculate the impulse response h of n. So for impulse response, we take x of n is nothing but delta of n, because we have to find the impulse response. If we have the input x of n equal to delta of n, then we have the output y of n equal to h of n, which is the impulse response. So we have taken x of n is equal to delta of n. Now y of n become y of n, which is nothing but h of n, is equal to delta of n minus 2 into x, not x, delta of n minus 1 plus delta of n plus 2. So we'll find the value at various index. Find the value of y of n. We will first put the value at minus 2, y of minus 2, which become delta of minus 2 plus 2 into, we will put this value minus 2 here, it become minus 2 minus 3 this is minus, not plus, sorry, and plus here we have value minus 2 plus 2 delta of n. So we will get a value delta of 0, it will become delta of 0. So at 0 index unit impulse have one value, and these are, this is 0 and this is 0, this is 1. Now we will look at y of minus 1, which is equal to delta of minus 1 plus 2 into delta of minus 2 plus delta of 1. This is 0, this is 0, and this is, all these values are 0, so we have 0. Now we look at value at y of 0, which is equal to delta of 0 plus, not plus, these are minus 2 into minus 1 plus delta of 2, and again we have delta of 0, so at this instant it is 1, and these two are 0, so we have 1 here. Now we have y of 1, delta of 1 minus 2 into delta of 0 plus delta of 3. Again we have minus 2 and y of 2 is equal to we have 0. Now y of these two values is nothing but we have h of n is equal to y of n is equal to h of n, and it is equal to 1 0 1, this is our 0 index value, 1 0 1, and minus 2 and 0. This is our impulse response. Now we will look at another example number 2, which is y of n is equal to 0.5 y of n minus 1 plus x of n. So in the question where we have the previous values of our output variable, this is our previous value y of n minus 1 of our output variable y of n. So in these questions we have given an initial condition. If initial conditions are not given, we will take that y is 0 if n is less than 0. All the output values are 0 when n is less than 0. So to solve this problem, we will put value y of 0, which is equal to 0.5 into y of 0, which become y of minus 1 plus and we replace x of n with delta of n. So here it become delta of 0. We have assumed that y of n has 0 values when n is less than 0. So here n is less than 0, n is equal to minus 1 here. So we have 0 value here, and this all becomes 0, and here it is delta of 0, which is 1. So we have 1. Now y of minus 1 is equal to 0.5. Not y of minus 1, y of 1. We have y of 0 plus delta of 1. Here we have y of 0, which is y of 0 is equal to 1. So we have 1 and 1 into 0.5 means 1 by 2. And here we have 0. So we have 1 by 2 and y of 2 is equal to 0.5 y of 1, where y of 1 is 1 by 2 and 1 by 2 into 1 by 2. And here we have delta of 2, which is nothing but 0. So we have 1 by 4. So y of 3 we have 0.5 into y of 2 plus delta of 3. And y of 2 is 1 by 4 and 1 by 4 into 1 by 2 is 1 by 8. So these value continue till infinity. So we will make the generalized form as we look at y of n, any value of n is equal to 0.5 into y of n minus 1, its previous value, plus delta of n, nothing but 1 by 2 power n. This equation satisfies all these values. If we have n of 0, we have 0 here and it become 2 of 0 power 1 and we will get 1. If we will put n is equal to 2, here it is 2 and 2 into 2, 2 2s are 4, we will get 1 by 4. If we put value 3, we will get 2 power 3, which is 8, we will get 1 by 8, which is this. So we have converted into generalized form. So this is all for this lecture. Sorry, I have missed some important things, like in this example we have a finite value in impulse response. So this is in this condition we called it as finite system or finite impulse response, and in this we have infinite values. We can put it will continue from 0 to infinity. So we call it infinite system or infinite impulse response. And the condition we have used here, that I told you, that y of n is 0 when n is less than 0, this index, this condition is known as relaxed condition. This is a type of initial condition that I have already told you. Okay, thank you for watching. आज का हमारा लेक्चर कंप्लीट हुआ, मिलते हैं नेक्स्ट टाइम। अस्सलाम वालेकुम।